Good afternoon, students. This is video 1.2, Geometric Tools, and your objective is to say, I can use postulates to describe relationships between the undefined terms of geometry. Okay, so our first definition today is going to be about undefined terms. And undefined terms are basically basic ideas that we really can't define. So I'm going to actually draw a circle and a box around that because I really should say can't. We can't really define them, okay? I know yesterday, or the previous video, we did point, line, plane, and we described them, but we really can't define them because they are these basic terms that we just kind of use. The next one is going to be postulate. And a postulate is really cool. Another word for postulate is axiom. And these are really just accepted statements of pure fact. So whenever you see postulate, it means that someone else has proved this, it's true, you don't have to worry about it. Okay? We get to benefit from others proving things. So what we're going to do now is talk about some specific postulates, and we're going to actually draw what a diagram would look like for each of these postulates. So the first one is through any 2 points, there's exactly one line. So let's actually do that. Let's make 2 points, a point and a point, point A, point B. There's exactly one line. So we're going to put a line through it. Bam. Okay? So that's basically what that postulate says. That is always a true statement. The next postulate says if 2 lines intersect, then they intersect in exactly 1 point. All right, so we're going to draw 2 lines. And here's another one. And up, they did exactly intersect at 1 point, and we'll label that point P, the point of intersection. Okay? The next postulate is going to be 2 planes intersect at exactly 1 point, or 1 line. Okay, so now we're going to go on to the next postulate, which is 2 planes intersect at exactly 1 line. So let's draw 2 planes. So here is 1 plane. Okay, so here are 2 planes. And it's clearly, you can see right now that these 2 planes intersect at 1 line. I'm going to draw the line where they actually intersect. So that's the line that they actually share. Just want to draw a line in, and we'll name that line R, cursive R. The final one here is going to be through any 3 non-collinear points, there's exactly 1 plane. So let's just make 3 points. Point C, A, T. And that means that we can draw a plane that contains these points. It could have been a different set of 3 points. We could have drawn a different plane. But again, as long as it's a plane, it works. Okay, so let's start with our examples. We're going to, one, it says, draw a figure to fit each description. Through any 2 points, there is exactly 1 line. Okay, so we need 2 points. Point A, point R. Now we will draw a line, exactly 1 line through the points. There we have it. Okay? Number 2, it says 1B. 2 distinct lines can intersect at 1 point. So let's draw 2 distinct lines. Call this one the blue line, line C. And we'll call this one, that's cursive C, the red line. This will be line N. And that would mean that now this is at exactly 1 point. They intersect, we'll call that point P. Okay. Now on to question number 2. Determine whether each statement is always, sometimes, or never true. Okay, so for part A, it says GH and HG are the same ray. Well, this actually is a problem because GH, the way it's drawn here, it shows that the end point is at G, like it is here. And HG, since it's a ray, H is the end point. So if we were to try and say that these were exactly the same, we're saying it doesn't matter where the endpoint is, and it actually does. So this could actually never be true. Never, ever be true. Okay? If it says G as the ending point, it has to be G. If it says H as the ending point, it has to be H. Part B. Ray JI and Ray JL are opposite rays. So we can actually draw that. This could be JL. And this could be JI. Opposite meaning they form a straight angle, and they do, because this angle here will create 180 degrees, and it's okay, they're both rays. J is a point, and it extends to I, or it extends to L. So this is going to always be true. So this is always. Last but not least, part C says a plane contains only 3 points. So let's make a plane. Let's make one. Here is a plane. And I'm going to, well, it says only 3 points. So here's a point, here's a point, here's a point. CRT. Well, this could be a point too. Oh, this could be a point too. M. So a plane itself is made up of an infinite amount of points. So this is also never true. So here we've come to our moment where we have our secret hot question, which is, how many segments can be named from the figure at the right? So you want to look at this figure and figure out how many segments. Remember what a segment is. Figure that out. Think about it. Remember to record your secret answer. The link to the Google Doc can be found at q2lflipmath.wordpress.com with the video now. It's much easier to just go there and click the link instead of having you guys type it in. Have a great night.